Hello friends, welcome to our channel Automation Community. Today we are going to see real-time application of PLC and HMI for metal sheet punching and cutting machines. You can see over here this machine is working fully automatically. So we are going to decode its logic and how it's working automatically. So before moving ahead, we need to understand the main components used in our project. So let us understand the main components. First of all, you can see this is the complete machine assembly. So I will divide this machine assembly in two parts. In this box, there are the two things or two process taking place, punching and cutting. How this is happening? You can see this big cylinder. This is the oil cylinder, or we can say hydraulic cylinder. This is the cutting cylinder. And below this strip, there is punching cylinder. When the cylinder advances and retracts, it is doing punching and cutting process. That is happening within this box. I will show you later. After that, on the left side, observe this plate. This plate has two main things. First, it has stepper or servo motor. And here you can see one cylinder. This is actually a gripper which will hold our plate or material which is to be processed. For example, if we energize this cylinder, it will hold tightly our metal strip, and if we release this, it will release our plate. That you will better understand later. Now, this is the proximity sensor to sense final position of this servo and gripper assembly. You can see. First of all, how this works. This gripper will hold our material which is to be processed, and this servo motor moves in forward direction, that is towards this machine. So it is actually feeding the raw material into this machine. So as you can see over here, it has reached to its final position, means now it cannot move after this. So this proximity sensor is used to sense the final position of this gripper and servo assembly. Now observe here, these are the two proximity sensors. These two sensors senses the final and initial positions of cutting cylinder. When it advances and reaches up to this distance, it stops and then comes back to original position. And when it comes back and it moves up to this distance, this proximity will stop it from moving further back. So these are the two proximity sensors for cutting cylinder. Similarly, observe over here, these are the two proximity sensors for punching cylinder. Below this, there is the punching cylinder which will punch the holes in the metal strip. Now observe this. This is the metal sheet or plate which is to be processed. Now this is the another important thing, which is the hydraulic machine. It consists of oil tank, oil pump. Here there are 4 solenoid valves. Here there are oil pipes. As you can see, there are the 2 cylinders. So 2 pipes for each cylinder. Now we will see it's working in different steps. So first of all, as I have told you, this gripper assembly has reached to its final position. So what logic will occur, that I have written over here. I am playing this, the actual video is in very fast, so we have to observe in the slow motion. As soon as the proximity sensor become on, first of all gripper will release and then motor will run in reverse direction. Okay, so this is the first step. This is actually I have shown you in the slow motion. Let us see what is the actual speed of this process. From this view, you will better able to see how gripper releases the plate and how fast the motor reverses because it has reached to end position. So now it goes to home position, and again cylinder will become energized and it will hold tightly this plate. You can see this plate, and then motor will run forward so that this plate can be feeded to our punching and cutting machine. So that process I will show you what will happen. Now gripper will energize, so it will hold tightly this plate, and our stepper or servo motor will move in forward direction. That means towards our punching and cutting machine, but in steps. That means it will start and then stop. So observe carefully. It is starting and then stop, starting and then stop, starting and then stop. This is how it moves forward. Now we will see what is happening under punching and cutting machine. So observe carefully. As the motor moves forward and motor stops, so as the motor stops, there is one punch, okay, and this proximity will increase counter. There is another punch, there is third punch, and this is the fourth punch. After fourth punch, observe this. This cutting cylinder has operated. It has moved downwards and it has retracted back to original position. This is very slow motion. Okay. Again, let me explain you. When there is one punch, then motor moves slightly and stops. When it stops, it punches again. Again motor moves slightly. So here you can see this process repeat for the 4 times. And when the counter value reaches to the 4, cutting cylinder is operated. So now let us see this process from different angle. Motor operated, punching operated. Again punching operated. Now motor operated one step and punching operated. Again motor started one step, punching operated, and finally the cutting valve or cutting cylinder operated. So this is also very slow motion to better understand the logic. So this whole process is operated through this HMI screen, and this complete process is controlled through this PLC system that you can see over here. So let us understand what are the equipments used in this project and what are its functions. So first of all, you can see this is the SMPS, which will obviously the power supply for our PLC. Now here it can be inputs. So inputs of PLC will be proximity sensors, the start stop button you see on the HMI screen, and its outputs will be connected to this relay, and through this relay its outputs will be the solenoid valves, servo drive. So this or servo drive will control the movement of motor. Here this is the main contactor. The purpose is, for example, if the utility supply is gone and then it comes back, we don't want the machine to be started automatically. It may cause some damage to property or equipment or a human. So in every machine there is contactor for manually on off when the supply is gone. These are the protection MCBs. This can be the heat sink for VFD or braking register for our motor. And below there is the terminal board for our input and outputs. And this whole system is made using Vicon PLC and HMI products. Besides this, through the HMI screen, we can select the number of punches in the plate, distance between the punches in the plate, and the length of overall plate that we want to produce. So let us again see the complete machine working in actual speed. So this is the actual application. This is how this plate is processed. This is the actual speed. You can see punching and cutting cylinder. This is motor moving in steps. Here you can see this is our actual product. There are punches and cuttings. So friends, reason to make such videos is to help you building the logic for real-time applications so that you can create your own programs for such applications. If you want to learn more content like this, stay tuned to our YouTube channel instrumentools.com. Hello friends, welcome to our website automationcommunity.com. Today we are going to see another real-time application of PLC HMI for glass products making machine. So we are going to understand the sequence of operation and its main components. So first of all, let us see what are the main components used in this machine. So as you can see over here, this is the spindle. This rotates our product. You can see it is rotating glass. After that, here is the burner. This burner is also controlled through PLC and HMI, its high, low frames and etc. After that, here you can see this is one chain drive and its motor is below this assembly. So that motor is simple induction motor that is running through this chain drive, which is rotating this polishing. So it is making some polishing or shape giving work over here. After that, here you can see there is a servo motors. So this servo motor rotates this arm and this arm is used over here for pressing or giving shape. After that, there will be another motor, servo motor below this assembly, which is used to move this assembly in this horizontal direction, or you can see the arrow given over here. We will understand the working of this machine. So as you can see over here, first of all, when we place our product, this spindle will start rotating at the desired speed given by user through HMI, and the burner also started. So it is heating and this is moving our glass object. So this is our first step. After that, observe this assembly. After that, what is happening? This assembly will move in forward, that is toward this glass, and this chain drive is operated. So this is rotated. Besides that, you can see this arm. This servo motor will run 90-degree forwards. So this arm will come down and press over here, and after that it will, for some time delay, it will remain as it is, and after that time delay this servo motor will reverse 90-degree and this whole assembly also goes in reverse direction. So let us observe this. So you can see first it is coming forward and this servo operated 90-degree forward. Now for some time delay it is remaining as it is. Now this servo reverses 90-degree and this assembly reverses. So in this way this process is completed, and after that the operator removes the final product. So this complete system is made using Vicon, PLC and HMI products. The reason of making such videos is to improve your logical thinking so you can write ladder logic for real-time applications. Thank you for watching this. If you want to get more examples like this, show your interest by liking and subscribing our YouTube channel. Meet you in the next video. Hello friends, welcome to our website automationcommunity.com. Today we are going to see another real life application using PLC and HMI. So that is the mask making machine. So today we are going to see in detail working or the logic behind making the mask, which was very important during the corona. And this is very interesting mechanism. So let us understand the each and every operation of this production line. So let us start understand its working, or we can say what is the logic behind making this process automatic. So first of all, you can see there are the three rolls, because this is the first material, this is the in between material, and this is the material which is towards our face. So these three rolls are feeding the three raw materials. There is the puller. This is the pulling mechanism. It pulls the three rolls. Okay. So after the rolls are pulled, what is the happening over here? You can see this is the one strip. If you have observed, there is strip around upper part, or we can say it nose, so which grips our nose. So this is that strip, and here the material is flat, but here you can see there is the shape. If you have remember, there is such shape in the mask. So this is the mechanical arrangement which creates these shapes. So here there is no any electrical actuator. uh, by this mechanical arrangement this is happening. Okay, so this is the machine is pulling the material, and this is pressing it, so this shape becomes formed. So this is the first step. What is the second step? Let us see the second step. So this is the machine. What it does, it seals the mask from all four sides, that is two horizontal and two vertical sides, and after that it cuts into uniform size. When the desired size is achieved, it is cutting through this cylinder, you can see. And here these are the chain drives. So this whole assembly is working through motor. You can see these are the chain drives, and these rollers, these are pressing, hitting and sealing, and then cutting in uniform size. So this is the second step. Now we will see the third step. So what is the third step? So actual speed of this machine is little higher, so we have to use two separate production lines for further processing. So we have to distribute this mask in two production lines. So the machine you can see over here, or mechanism, this is also another interesting mechanism. It will distribute the mask into production lines. So how it will do, let us see. Observe carefully. Here there is a sensor, red light you can see. When it senses the mask, alternate motors are activated. Okay, let me repeat this. One time this motor activated, second time this motor activated. Okay, similarly again this motor will be activated. In this way it is distributing the mask in two production lines. Okay, so this is the step 3 and working of this distributing machine. Now the process we are going to understand is really very interesting, and it's very unique and very creative. Let us see that. This is little complex, and even though I made this in slow motion, this process is very fast. So please try to listen this or watch this part 2 or 3 times for better understanding, and carefully observe over here. This is mechanism, and here I have written the comments. Okay, so let me play this. This is already a slow motion but yet very fast. Cylinder is moving up, servo is rotated 90 degree. This will hold the grip, will hold the elastic. Again servo is rotated 90 degree. Now cylinder will move downwards, and now heater will move downwards. So this electric band is stitched to mask. Heater up, now it will release the band, and cylinder move upward, rotated, and again it is starting from the beginning. I know this is very fast, but this video is already very slow motion. So let me repeat this. You also have to understand 2-3 times. First, it is okay. Let me play from beginning. Okay. Cylinder upwards, servo rotated, cylinder downwards, gripper hold the rubber, cylinder upwards, again servo rotated 90 degree, cylinder downwards, heater downward, this is the heater. Now heater will move upwards, okay. Now it release, gripper release and cylinder is move upward, servo 90 degree, and from here this process is repeating. But this is happening 4 times. You can see 2 cylinders over here and 2 cylinders over here. So all 4 cylinders same working is being done. Okay. Now we will understand this below assembly, which is bringing a new rubber piece every time. So let us understand that. So this is also very interesting mechanism. It is very simple but very unique. Okay. Let us see that. So here it holding rubber and cylinder is moved backwards. Okay. So this new rubber piece came. Now what will happen? This servo arms, this will hold the rubber, and here it will cut and here it will release. Gripper will release so that this rubber can be stitched to mask. Now here new rubber came, it holded and cylinder retracted. Okay. Let me repeat this. So it will hold the rubber, cylinder is retracted. Now it will wait. When the sequence will operated and this servo will arms will come here to hold this rubber, here it will release and this will cut the rubber, and now again the cylinder will be advanced and from here it will take the new rubber piece. So I hope you understanding it properly and liking it. So here is our complete assembly is completed. This whole production line is made using Vicon HMI and PLC products that you can see from here. This is the HMI control buttons, and here you can see this is SMPS, our Vicon PLC IO modules. Here the relay modules, and these are the servo drives. So this is the real life application. Let us again see the complete process. So this time you will understand each and everything clearly. From this roll, material is coming, shape is given, sealing and cutting is done. It is distributing the mask into production lines. As this process is completed, this is moving one step. So here also there is servo drive and there is another conveyor which conveys this ready completed mask to our final stack. So So friends, I hope you enjoyed this video. So if you want to see more real life applications like this, show your interest by liking and subscribing our YouTube channel. Meet you in the another video with another real life application. Hello friends, welcome to our channel instrumenttools.com. In the series of real life PLC and HMI examples, today we are going to see PLC stone cutting machine. So this is, you can see, a smart stone cutting machine which cuts through very precisely. It works fully automatically and it can work on slate, granite and marble slabs. So this machine consists of IoT enabled HMI. So we can work on Internet of Things through this HMI also. Besides that, it has LXV5 series Vicon PLC and servo drives and servo motors for 5 axis control. So you can see here there are 5 axes and 5 servo drives and motors, and which can help us to make different slate, granite and marble slabs. This is the interactive HMI screen for each shape, and because of Internet of Things, we can operate this from remote location also. And this is how the real panel looks like. You can see these are the servo drives, and you can see it can make any shapes with very precision. It has wide portfolio of products, and you can see this is the A-axis motion. It can cut in curvature also, and it also has the visual positioning sensor. You can see the current position of the grinder. This is the overview of the complete machine. So you can see it can cut in slanted position and complex work also. So let us understand the working of this machine and also its construction. So let's start. Here you can see this is one standard plate or a standard shape. So manual cutting of this is possible. But when you want shapes like this, manual cutting is little difficult and we can't do same shape we want to do mass production. That's why it's better to use this smart stone cutting machine. Manually cutting these shapes with so much accuracy is time consuming and also require high skilled manpower. This is the reason we need this smart stone cutting machine which has HMI, PLCs and servos. And you can see this is the complete machinery. But how does it work? This is only the reason why we are making this video. So let's see. This is the complete overview of the machine, and I'll show you from this slide only. You will be able to understand the most of the things about the machine. So first of all, in the any CNC machine, there are three main axes which are called X, Y and Z. So here you can see this cylinder. Here there is the movement for Z axis which moves this cutting wheel or cutting motor grinder in up down position. So here you can see up and down Z axis. Now this is the whole tray. In this tray, this assembly can move towards right or towards the left. So this axis is denoted as X axis. So it has its own motor, and here you can see this is the flexible cable arrangement because this motor here there will be Z axis motor and X axis motor will be touching to this platform. So if the motor rotates, it will move this assembly in right or left direction. And this is the flexible cable because this assembly has to move anywhere. So the cable also moves along with this. Here also you can see if this assembly moves backwards, okay, so that is the y-axis direction. It can move backwards or come forward. So this is the cables for y-axis. Now this is the common in every machine. But what is the new in this machine? That are the a-axis and the c-axis. So here there is one main motor which only rotates the grinding wheel or we can say cutting wheel, but a-axis can rotate this complete assembly in 360-degree. There is the c-axis only. So in previously we have seen that this right now this plate is vertical completely 90-degree to this board, but due to c-axis we can make this wheel slanting. So we can cut slanting angles also. And this wooden bench you can see this is our workbench where we place our marble or granite which we want to process, and through this panel control panel we can operate this machine. So all these axes consist of servo motor which is controlled through PLC, and that PLC is controlled through HMI screen. So this is the complete overview of the machine. Operation of each axis in this machine. How all the axes actually work. Here you can see this is one sensor and there is one X mark over here. So we have to focus on this portion to observe the movement of A-axis, how the A-axis actually works. And this assembly is moving left of this slide. Okay, so that is the X-axis operation. So in this way we will see operation of each axis one by one. So let me play this video. Observe that this X will move toward this proximity sensor. The distance between X and this sensor is reducing. Okay, so this is how it rotates. You observe this plate. Here you can see the shape. It is moving in X direction and it rotated the plate like this. So the curvature is formed over here. So this curvature, you can see this rotation. So this rotation is due to A-axis. Now it will go little upwards. So that will be Z-axis. You see it going upwards. Now again it will come back. It will come down and then it will come back. Now again observe. Here you can see there is the movement. X is moving far from this sensor. So this wheel is rotated. What is the use of this A-axis? So observe these shapes. By only varying the X and Y, we can't make this operation. These curves are possible. You can see over here also. These curves are possible due to A-axis because A-axis rotates the blade like this. Now in this video again we will see the movement of A-axis which will be clearly visible to you. So you can see this motor is rotated with the angle. Again you can see. So this is the movement of A-axis. We will understand the C-axis operation. Here you can see the cutting wheel is completely vertical or perpendicular to this plane. But here you can see the cutting wheel is slanted. So this is the operation of the C-axis. You can see the complete motor is slanted and it is moving forward. So this is the movement of C-axis. Here it is coming in X direction and also C-axis is operated. It is going upward. So Z-axis is operated and it is going upward. Now it is moving backward. So Y-axis, this cutting wheel now become vertical. So that was the C-axis and it gone left. So this was the X-axis. Let me repeat this from here. Observe carefully. So in this video you will see operation of all axes. Let me play from here. So right now X-axis and C-axis are operated to this position. So now Z-axis will be operated and it will move upwards, that you can see from here. Now there is a question. Here there is no any sensor to determine that it has completed its shapes. So how it is operating? So every servo motor has encoder within itself. So the motor and encoders are on the same assembly. So through the encoders, drives get the feedback that it has traveled the required distance. So what in the PLC logic we will write, store the pulses coming from encoder. By the pulses coming from encoder, we will count the pulses by high speed counter. Then we will do comparison of the counter value. If the required distance is achieved, that means if the required count pulses are achieved, based on that we will give reverse and forward commands to our servo drives. So this is how the programming works. Now we will see it is going backward, so y-axis, the wheel become vertical, so c-axis vertical this, and it is moving left direction, so this is the x-axis. Here you can observe this is the application of c-axis. This cut you can see, This is not possible with the ordinary XYZ axis. So this slanted cutting is possible through C axis only. And this process is called chamfering process. Now we will see what are the main components through which this machine is built. So let us see that. This is the complete architecture of our project. Here you can see that we have used IoT enabled HMI screen which is connected to our PLC through RS422 communication and PLC and vision machine. So this machine also has, as I said earlier, it has the visual sensor also which can detect the current position of the cutting wheel. This is the sensor and this is the module for this sensor, and it is connected to PLC through this RS485 communication. So based on this, these pulse outputs are given to servo drives. So you can see there are the 5 servo drives for 5 axis servo motors, and so our input is stone material, and that finished products we get required shapes. So this is the complete architecture of our project. So here you can see again, this is the HMI screen which has lot of parameters, and this is the actual panel MPS for PLCs. Outputs are operated through this relays and other outputs like this servo motor. So let us discuss wiring about this servo motors. Here you can see L1, L2, L3. This is the main supply for this servo drive. Now here you can see UVW. So this supply is for motor, and this upper one is for the encoder that is coming from, that is connected to motor itself, and this is the communication cable coming from PLC. So same configuration is for all machines or all servo drives. So this is how the actual panel looks like. Here you can see there are the 5 servo drives. 3 servo drives are bigger because of main XYZ axis, and 2 servo drives are smaller because A axis and C axis doesn't have much load. This is the complete panel. Here you can see it has wide application and lot of shapes can be formed through this machine. These are the shapes along with their names. Besides this, it also has other advantages like this is very flexible. You can make any shape. This is very stable. It has very high accuracy and precision, and it also has more functions compared to ordinary machines like slicing, specially shape cutting, profiling, drilling, milling, grinding, and etc. This is how the PLC operator screen looks like, and the vision control, especially vision control screen looks like this. Here you can see there are the dimension, and based on this dimension the cutting wheel will be operated. This is the screen. You can see there are the shapes. Based on the shape you select, the respective screen will open. Like you can see, this is the screen for profiling that you can see from here. If I click on this button, this screen will open. The question is, why this machine is called smart machine? So the answer is, the whole project you can see from here, this HMI is connected to internet, and through the internet we can access it through website or through mobile application. It has cloud SCADA, that means we can operate it from remotely, and it can support other desktop tools. So this is how this machine is made smart machine. So what are the advantages of making this machine smart? So it can be operated from remote location. We can debug, that means we can diagnostic or download from remote location also. A maintenance engineer can work from remote location also if there is any update or revision in the programming, so that saves the traveling expense and cost also. Can provide machine maintenance scheme. So how it is done? Machine itself can generate the alarms for preventive maintenance, or if there is internal fault in any sensor is faulty or like that. So that we can also see the real time status of the machine, that how many products have been processed, what is the current shape being processed through application HMI or from remote computer also. Last but not the least, the equipment can give alarm function via email or other methods. So even if the operator is not available there, maintenance team can know about if alarm is coming, so they can go for troubleshooting and servicing it. So after watching such videos, you will definitely give new ideas for making your projects. If you want to get more real life examples like this, show your interest by liking and subscribing our YouTube channel. Meet you with another example in next video. Hello friends, welcome to our channel instrumentools.com. Today in the series of real life PLC examples, we are going to see EtherCAT servo application using PLC. Yes friends, as the name suggests, EtherCAT means there will be some communication part, and servo, that means we are going to see the application of servo. Here on the board you can see the servo arm is moving and it is creating different patterns automatically. So there is infinite possibilities to create these patterns, and this is the complete panel or wiring arrangement. Nowadays there are many projects on the servo arms like servo clock. You can search on the internet, and as a hobbyist also you can make this project as a final year project or as a hobbyist also, and you can create your own patterns. But it is always curiosity how the system works. So today we are going to see that part only. So this is the complete system made by using Vicon servo motors, Vicon PLC and its Vicon servo drives. So this is how the complete system looks. Now we are going to see each and every detail about how this project works. You can see just by using a simple single PLC, we can control a lot of servo drives. This is the power of EtherCAT cable. So this is the complete construction and wiring. We are going to discuss it very soon. First of all, this is the front slide, okay? So you can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16 points. So you have to guess how many servo motors we will require for this. So this is the reason I am showing you this. You won't believe that these 16 points are actually controlled through 32 servo motors. Yes friends, you can see the numbering also. This is the 32 number and starting from 31. And before that, let me pause this. You can see the motor has two terminals. So friends, can you guess what are these two terminals and write the answer in the comments? So you can see there were the 16 points on the front door, but we are using 32 servo drives. Why it is so? So we will see it now. From here we can see this is the one, but actually it is not one arm. From this picture it is clear that there are two arms. So each arm is controlled by separate servo motor. So this will be controlled by servo motor 1 and this will be controlled by servo motor 2. So in this way, these 16 points are controlled through 32 servo motors. Therefore, we will require 32 servo drives for this. And because there are some patterns that you can see over here. Right now, it is vertical only, but you can see. So this two has different movements. So that's why we have to use two servo motors for each point. So this is the things we can only come to know when we see the things from closer view. Now we will understand the wiring in detail. First of all, you can see this is the Vicon LX6V PLC. This green cable is the Ethernet cable. So each PLC is connected through this Ethernet cable. It is looped. So what's the use of this? Here you can see in the inputs, outputs, we haven't used anything. Everything is controlled through this single cable only. Now we will understand the wiring of this servo drive. First of all, here you can see L1, L2 and L3. So this is the main input supply, and here we can see it is single phase only. So it is the main input supply given to the drive, and from here you can see the main input supply is linked to each servo drive. Common power is coming to here and then it is looped to each and every drive. So this is how we will give input power supply to all the drives. Now here you can see UVW. So this is given to servo motors, okay, and this is the encoder cable coming from the servo motor that is connected over here, and here Ethernet cable is connected, and this is the Vicon VD3E model servo drive. So this is how this complete wiring is done. You can see the communication cable is looped, input power is looped, and here motor and encoder connections are done. Now we will see the connection to the motor side. Yes, I have asked you what are these two connections. So first, this is the power cable for the servo drive and this is the encoder connector, because nowadays most servo motors have inbuilt encoders. So this is how the servo motor and servo drives are connected. As I have said earlier, just by using one Ethernet cable, we can control all the 32 drives. Otherwise, we have to use lot of input outputs to control each drive, because as you know, we have to give drive enable, pulse number, frequency number to each drive. So you can assume that there will be lot of input output wirings required. But by using Ethercat, all complexity is reduced and the system is made simple. So this is the application of Ethercat. Now we will see the logic required to create this project. So first of all, we have to do communication settings in the PLC and in the servo drive. Means in each servo drive, we have to do some communication settings. So what are these communication settings? So you can see from here in the PLC, either we have to manually set each of these parameters, or we can, if based on the PLC software, communication blocks are already available, where we have to set baud rate, data length. Baud rate means 9600, like that, 4800 and like that. Data length means 7-bit, 8-bit, parity, odd even parity, stop bits, 1 stop bit or 2 stop bits. Now there comes a station address. So this is the important thing. Say for example, we are giving 0 station address to PLC or 1 station address to PLC. Then what will happen when we are programming communication settings in the servo drive? At that time, in the each servo drive, we will give different station address. So for example, if this PLC wants to write some command to this drive, so this drive should have unique station number. Then only this will be able to write some data to this servo drive. So this station address is like our mobile number, that we all have a unique mobile number. So that is how we communicate with each other. So in the same way, we have to give different station number to each of the equipments connected via Ethercat. So for example, if this want to write something over station number 10, so servo drive connected as station number 10 only will be affected. So this is the important thing. And last, there is the timeout settings. Now in the communication settings of the drive, there are the same things only, like baud rate, data length, parity. So we have to set these things in both PLC and servo drive. After that, we have to write logic for how each of the servo arms will move, means how many degrees it will move in each step. So that is the next program. So here you can see, as discussed earlier, we can see 16 points over here, but each point has two servo arms. So this is the servo number 1 and 2, 3 and 4, 5, 6. So in this way there are 32 servos. Okay. So initially all the servos are like this position. In the next step, what will happen? All the odd number of servos like 1, 3, 9, 17, 25, odd number of servos will move 360 degree. So it will come to original position, and all the even number of servo motors will move 180 degree. So you can see the next step will look like this. The odd number has traveled 360 degree, so came back to original position. But even number has traveled 180 degree from initial position. So the complete pattern looks like this. You can see initially it was like this. After the step number 2, it will look like this. Now what will happen? Now next step, what we want to do? We want to draw one square. So for that square, here this arm will be rotated 270 degree. So it will travel 180 degree and 270 here. Similarly, this will travel for 270 degree. So it will go to here. Now what will happen? All this middle 1, 2, 3, 4, 5, 6, 7, 8. This middle portion, all the servo drives will move for 270 degree. So what will happen? This will become horizontal lines. All this middle become horizontal lines, and in these four corners, here, here and here, what will happen? The number 1 will move for 90 degree only, and here 25 will move 90 degree backwards. After that, this two and these two things will remain same. So the complete pattern will look like this. As I said, this middle portion will become horizontal lines. So you can see, if all this rotates 270 degree, that will become horizontal lines that you can see from here. And the corner, after that, you can see this and this has remained as it is. And these four corners will move 90 degree to make these corners. So complete pattern will look like this. After this, what will happen? This number 4 will go 90 degree back. This number 12 will go 90 degree back, and this 10 will become 90 degree forward. So it will make the smaller square, and all others will be same. Like this 18 will move 90 degree back. This 20 will move 90 degree forward. This 28 will move 90 degree forward. So in this way, it will become smaller squares. And after that, what will happen? So this is the final step. After this, it will come back to original position. So thanks for watching, friends. If you want to learn more real life examples like this, show your interest by liking and subscribing our YouTube channel. Meet you in the another video with another real life example. Today, in the series of real-life PLC and HMI examples, we are going to see complete production line of plastic door frames and window frames production line. So let us see that. So first of all, let us see the complete production line. After that, we will discuss each component in detail. So this is the complete automatic production line from beginning to the end, the fully automatic system. This is the corner welding machine. This is pelletizing machine. The finished products are pelletized, and after comes the corner cleaning machine. And this whole system is made using Vicon PLC, HMI, servo drives, and servo motors. So this is the actual PLC and HMI panels. You can see in this way the system is completely automatic and it can operate in different axes. See, this is movement through servo drives and servo motors. It is clamping, declamping through pneumatic cylinders. There are different kind of corner cleaning machines. You see, this is also a corner cleaning machine. This is how the actual PLC panels and all looks like. And each machine has different HMI and PLC panel. So it can stack up to 20 ready products. So this is how the corner cleaning machine works. The process of this production line starts from the welding machine. So first of all, let us see how welding machine works. So before that, we need to understand the process of welding plastic frames. So here you can see this. There are 4 different sides of plastic frame, and these are the corners. So these corners are heated by heater. After heating up to certain temperature and desired time, after heating the all 4 corners, these corners are pressed together, applying some pressure to it. So these are welded. You can see this corner. These are the welding of plastic frames. So this is the complete process. Now we will see actually see it is moving in different axes. First it is moving in one axis. After that it is moving in another axis because there will be different size of door or frames. So based on that it will adjust accordingly. Okay. First it will move in one direction. After that it is moving in another direction. So it will adjust to the size of door. After that what happens? You see these cylinders came downwards. So here it will clamp our frames. Okay, let me play this. So in this way, first it will adjust to the size of frame, then it will cylinders will come down to clamp the frames. So after that what happens? Heater comes out. So as discussed here, first it will clamp all the 4 corners or 4 sides, and then heater will come out. So the same thing is happening over here. Okay, it came based on the size of door. It holded the frame, and then it will little move backward and heater will come out. Then for certain period it will remain there only. After that heaters will go back. So observe carefully. This is the complete process. Let me show you with example. So here you can see. So in this way, these four frames are kept. Okay, four sides. Now it will clamp. Okay, this clamped. After that, heater will come out. After certain period, this heater will move back, and all the pieces will be jointed together with each other. Heater move back, and you see the movement of this cylinder. Okay, movement of this clamp. It moved so that this side frame can be joined to this side. Same process occur to all the corners. Let me repeat from here. Observe this corner. After the heater moved, this clamping moved towards this clamp. So this both sides can be joined together. So in this way, the welding process is done. What will happen after this? These cylinders will move upward, so it can unclamp this, and these products will be dropped to this conveyor. And from this conveyor, it will convey our products to corner cleaning machine. So now the next step is to understand the operation of corner cleaning machine. So basically it is one kind of CNC machine only, because it moves in different direction and there is one spindle in it, works like cutter or grinder. So first of all, through this conveyor, the products are brought to corner cleaning machine. So this is, both of this is corner cleaning machine. So let us see that. You see, product is brought. After that, what happened? When the desired position is achieved, this conveyor moves downward. After that, this cylinder, pneumatic cylinders will rise up and it will tightly hold the frame. Okay. Now this machine will move as per the size of frames, and another pneumatic cylinders will come downward to hold this tightly. And here you can see this is the movement of servo motor in upward direction and horizontal direction. So in this way, it will clean these corners. You see, it is moving upward direction and horizontal direction based on the desired pattern. After that, again it will move. This complete is moving forward. So there is another servo drive, and here it is cleaning through this, and now it is rotated. So for rotation also there is another servo drive. Okay, so as you can see, one for horizontal movement, one for up down movement, and one for this rotation. So total there will be 3 servo drives for this corner cleaning machine and one motor for this moving this spindle. Now it will go downwards and it will clean from downward direction. So again it will move in horizontal direction. Now again it came backward after cleaning, and again it rotated. So again angle motor operated. So in this way cleaning is done. So it unclamps. Cylinder moves upwards, so it unclamps the frame. And again this conveyor will move upwards, and after that this conveyor will start and take this to pelletizer machine, because this is now complete finished product. Okay, so it is taking it to next step. So before going to next step, let us see again the corner cleaning operation. Here you can see the laser over here. So this complete system is tracked through laser movement also. So you can see how machine operates on the HMI screen through pattern. Okay, so this is why there is a laser detection also. So first you can see it is moving upward, then in horizontal direction, again upward. In this way, it cleans the corners. Now we will see the last stage of our production line, that is the pelletizing machine. This is nothing but taking the finished products on the pellets. So that's why it is called pelletizing machine. So first of all, let us see how it operates. So first of all, these arms will come in downward direction. So one servo motor will be for this upward and downward direction. After that, you can see there are pneumatic cylinders which will be advanced and it will clamp this frame. So this frame can be held. Okay. You can see it clamped. Again, this moved in upward direction. So in this way, it holds our door frame or window frame. That is our complete finished product. So first of all, from the corner cleaning machine, the finished product comes to pelletizer. After that, pelletizer will pick it up. It will move in another axis like this. You can see it is moving in one direction. When the desired position is achieved, it will stop. Okay, now it will stop. And now this servo drive will move in downward direction. Again, when the desired position is achieved, these cylinders will declamp or move backward. So it will release this frame and frame will drop to here. So in this way, it can also count and it can stack up to 20 products in one stack. And after that, it will stack over here. So in this way, this machine automatically works. Okay. So this is the pelletizer machine and this is its panel and HMI. Each machine has different PLC and different HMIs because these are three different sections. So there are three different operations. So this is the complete overview of this production line. So again, let us revise from beginning. First section, first panel will be there for corner welding machine, which will have one HMI, separate HMI for welding machine and separate PLC. After that, this PLC is communicated to different servo drives. The welding machine will adjust itself in different direction based on the size of frames. So for that, we will require servo drives. There is temperature controller. As I have told you, there will be heater to heat these plastic frames. So there is temperature controller and there will be relay for solenoid valves, and these solenoid valves will operate pneumatic cylinders. So this is for clamping the frames as I have shown you. So this is the overview of corner welding machine. Now we will see the overview of corner cleaning machine. So again, in the corner cleaning machine, I have told you there is horizontal movement, vertical movement, and the spindle is moving with angle. So there are three servo motors for that. Besides that, I have told you there is one laser wrenching machine and there is also relay solenoid valves and cylinder because PLC operates the relay, relay operates the solenoid valve and it will operate the pneumatic cylinder. So this will clamp the door frames, hold the door frames tightly so that cleaning or grinding or cutting process can be done easily. And at the last step, there comes the pelletizer. So in the pelletizer also I have shown you, the pelletizer moves in upward, downward and horizontal in different directions. So for that, there are servo motors, servo drives. Okay. So this is the complete architecture of this production line. So now let us see what are the benefits of doing all this. So first of all, we will see the advantages of corner cleaning machine. So it can weld very precisely. There is no blacklash, means there is no wastage of products like wrong welding or like that, and one-time welding. In one time only, it can weld all four corners. Now we will see the advantages of corner cleaning machine. First of all, there is high productivity, high accuracy, and as I have told you, there is laser scanning demonstration, means in which path the machine is moving, that path you can see on the screen also. And there is one-click path generation, means whenever there is any new pattern, that can be easily made just by giving this pattern to HMI drawn from HMI. Last but not the least, we will see the advantages of pelletizer machine. So as I told you earlier, it can stack up to 20 window frames in one stack. It can neatly and efficiently stack our finished products. And the best thing is it is communicated with the other machines like corner cleaning machines. So there is no any human operation required to start and stop this machine. This machine is operated by itself. So this is all for this video, friends. If you want to see more examples like this, show your interest by liking and subscribing our YouTube channel. Meet you in the another video with another real life example. Hello friends, today in the series of real life PLC and HMI applications, we have came with another interesting application, that is PLC automatic bag feeding and packing machine from Recon machines. So before understanding the machine operation, let us see the complete production line. So let us see that this is fully automatic machine operated from Recon PLC and HMIs. You can see this is its panel, and this is how fast and how automatically this works. Complete production line, and it has lot of servo motors. So these are the servo drives for that, and these are the finished products coming from this conveyor. In one circle there are two production lines. Mean in half circle one production line is completed. So the same process is happening in the another half. So let us try to understand the operation of this automatic machine. So for that, we will step by step follow this flow chart. First of all, prefabricated bags are placed in the machine. After this, machine pick up the bag and it will give it to manipulator. What manipulator will do? Main center machine, it will clamp the bag, and clamp narrows down, and then turntable, that is the center table, rotates for one step. Okay, so up to this we will see a video in slow motion so that we can understand this. So okay, so here you can see prefabricated bags are put into the machine. Here the cylinder rises, and by creating vacuum over here, it will pick one bag and again come down. After that, observe this assembly. There are the two arms. One is the this arm, that is used for coming backward and going forward, and another is this arm, that is rotating, picking the bag and giving to turntable. So carefully observe these two things. Here the cylinder comes upward, pick one bag. After that, this arm move backwards and downwards and picks, clamps the bag and give it to turntable. Again, so this is controlled through servo motor. This is coming backward, and this arm is turning downwards and again turning upwards. So you see the two servo motors are used over here. That is picking one bag and giving it to turntable. Besides this, as shown in the flow diagram, this turntable has clamping arms that will hold the bag, and then this turntable will rotate for one step and move to another station. Now again coming to the flow chart. So in the third station what happens? Clamps narrow down, and the upper suction cups open and the lower suction cups open. After that, the bag support manipulator will lower and open the bag. So just summarizing this, here the process is to open the bag. So again, let us see the video in slow motion. So here you can see this is the upper section and lower section. First of all, what happens? You see this is the clamp of the turntable. It will narrow down. Okay, this will move slightly toward this side and it will move slightly toward this side. So we can open the bag. These are the lower section and upper section cups. Here also the vacuum will create it and these arms will open the bag. Okay, so you see, and these are the another assembly which is used to open this bag. Okay, so observe the sequence of this operation. First it moves forward, after that it rises upward. Okay, then it will go backwards, then it will come down and again it will open. You see this also widens. In this way it will open all the bags. You see, so this is the complete sequence to open the bags. Now again going to the flow chart. After this, in this video, this feeding means our raw material which we want to pack like snacks or anything. So that is called feeding. Feeding and weighting of that material is not shown here. Directly it is poured in the opened bag. And after that table rotates, clamp widens, and while we are pouring the material in the bag support manipulator rises. So this thing we will see. Let us see over here. Here you can see this is the bag support manipulator. After the bag is open, here there is one plate which supports the bag because we will pour material into it. Okay. See, this plate is becoming up and down. Okay. Right now it is downward. When this bag will come to here, it will rises up. You see, now it rises up and touch to bag. Again coming to the flow diagram. After this, what happened? It moves to next station, that is the heating and sealing. And after the heating and sealing, it will become cold and the bag is released to conveyor. So let us see that. So after the material is poured, it will come to this station. Here, this widen up. These clamps will widen up and this will heat the bag. So the bag is sealed. In the next step, it is cooled and then released to conveyor. And the final product will be dropped over conveyor. So this was the complete automatic process of this automatic feeding and packing machine. If you want to see more real life examples like this, show your interest by liking and subscribing our YouTube channel. Meet you in the next video with another interesting example. Hello friends, welcome to our channel instrumenttools.com. Today in the series of real life PLC and HMI application, we are going to see automatic carpet washing machine. So here you can see this is the complete overview of the machine and you can see how efficiently the space is used over here to create the electric panel. It is within the machine frame only. Let us see the complete machinery operation. So this is how the complete machinery is working automatically towards the carpets. You also know washing clothes itself is difficult, especially when it is hard clothes like jeans. So manually washing these heavy carpets is very laborious job. But here in the machine you can see it is very easily washing it without any hard work. So these are the brushes which are moving from one side to other so that any dust or stains on the carpet can be removed. And there is also one screw scrubber, which is continuously on so that minor dust or high dust particle can be removed from the carpet. And this is the final area. Behind this, the carpet is washed through detergent. And here in this part, this wiper removes excess of detergent from the carpet. You can see from here, a fresh water is spraying over it and it is removing the dirty or detergent water from the carpet. And automatically it is moving from one end to another, like forward, reverse, like that. Here you can see for the first time, the operator has to roll this, but after that, you can see these rollers are moving. So automatically it rolls our carpet. Let us observe again. Initially, you can see these sprayers are off, but as we start to roll this carpet, the sensor senses, and you can see this sprayer has started to finally wash these rolls also. So this is how the completely automatic it is. Now let us see how this machine works automatically. So there are some things which are on by default when we turn on the machine, and that things are like main conveyor which is moving the carpet. Okay. After that, screw scrubber that we already seen, that screw scrubber is already on. Okay, so you can see this is the screw type scrubber which is moving hard particles from the carpet. After that, water jets, detergent water jet and fresh water jets that are always on. And the brush motor, again you can see this brush motor is always on. It never stops. Just its forward and reverse is based on sensor. Other thing that rotating this brush motor is always on. After that, there are two moving parts which are moving from one end to another. So that movement is due to sensors only because it is moving from one end to other. So we require flexible cable tray like this because our wire also moves from one end to another with motor. That's why such kind of cable trays are used. Now here we will see, you can see it is moving from one end to another end and there is sensor. When the sensor detects this, it is moving in reverse direction. So here you can see now it is moving towards this end. And here also there is one sensor you can see over here. So when it senses it will move back to that direction. So this is the simple logic. After this, here also there are sensors. You can see this is photoelectric sensor. When this wiper comes to this end, so its rays are reflected from this blue plate to back, and at that time it reverses its direction. And such arrangement is also available on the next end, that is over here also. So let me show you. So you can see it reflected, so it is starting moving in this direction. Right now the carpet has not reached to here, so this water spray is also off. Now observe carefully. So here also you can see there is one blue plate. So this time when the slider will come to here, that is this wiper will come to here, you can see there is also sensor over here also at this end only. When this photoelectric sensor reflected back, the wiper changed its direction. Now we will see the control panel of it. So here you can see there are the main MCBs and some VFDs because there are main conveyor, screws cover, motors for this. Besides that, there is also Vicon PLC and Vicon extension modules. So these are for inputs, outputs, and this turn ons the contactors, and each contactor have their own MPCBs. So this is the complete panel. As I told you earlier also, how smartly they have used the space to create the panel within the machine only. Generally, there is the separate panel box besides the machine. So this was the complete automatic carpet washing machine. I hope you have get at least some new ideas from this video. If you want to learn or see more examples like this, show your interest by liking and subscribing our YouTube channel. Meet you in the next video with another interesting example. Hello friends, welcome to our channel instrumentools.com. Today in the series of real life PLC and HMI examples, we are going to see 3-axis non-metal cutting machine. So this machine actually looks like this. Here you can see this is moving in X and Z axis and it is punching shapes in the leather. It can cut leather, rubber, foam, cardboards, floor material and carpet. And this is the y-axis movement that you can see, and here you can see this is cutting the shoes, and this is made using Vicon HMI, Vicon PLC and Vicon VD2 servo drives for X, Y and Z axis. So you can see this is X axis. Now it is moving downwards in Z axis. Now again it is moving in X axis. So this is controlled through HMI where you can select shape, size and timing, etc. So here it is cutting in leather, this is foam. Here it is cutting cardboard and this is cutting in cloth. This is, you can select shape from HMI and you can see this is cutting the cloth material. So this has very wide applications and this is made using Vicon technology products. Meet you in the next video. Hello friends, welcome to our channel instrumentools.com. Today in the series of real life PLC and HMI example, we have come back with another interesting example which is automatic horizontal packing machine. Let us see that. So this is a universal kind of machine which can pack variety of products from food, medicines, toys and lot of things. You can see over here plastic bottles. So this is fully automatic machine using PLC, HMI, servo drives. Okay. You can set its length and its cutting as per your requirement. So this is very easy to download softwares. This is the HMI software. You can also use delicate products in this machine like glass, and you can see over here, and it has lot of other features like that you will see over here. Empty cutting prevention, okay, material cutting prevention. Besides that, it has reverse cutting. You can see this is the reverse cutting mechanism. It can offer fixed length or various length packaging also. And we can also pack delicate products like this. Okay. It is fully automatic. Here you can see the temperature controller of heater, and this is made using Vicon products. So let us understand the operation of this machine step by step. So the first step that is involved here is wrapping the plastic bag. So let us see that how it works. Okay. So as you can see, as the product passes from this conveyor, in one way it is acting like a buffer. Once this product is packed, after that only it allows other product. Here you can see there is one sensor which senses the product. If product is not here, it will not pack that particular section. So that was the empty product prevention from packing. After that, you can see below here there is roll. That roll is coming from here, and from this mechanical guides, the roll is forming a shape like this that you can see from here. Observe this end part, how this roll has formed its shape like this. So this was the first step, wrapping a plastic to the product. After that, here comes the second step, that is the sealing part. Okay, so again observe this. Here you can see, so this is the second part, that is sealing. Now the wrapping is completed. So what it will do, it here the two ends of plastic are brought together, and after that it will do sealing. Okay, so let us see that portion also. Here also you can see there is a control panel, and these are the temperature controllers which hits the heater, and that heater will seal the plastic bag. So let me show you. Here you can see this is the second assembly. These are the rollers. This roller bring the two end of plastic together, and here this is the heater. It heats the or seals the plastic. So this is the second step, and after there comes the third step, that is the cutting. So as soon as the one product passes, it will cut accordingly. So let us see that cutting part. Here you can see there is such a mechanical arrangement is such a way that exactly as the one piece comes forward, it will cut this product. So in this way, these packets are cutted. So there are three simple steps in this process, and remaining are the conveyors and the sensors. So this complete system is made using these automation products like Vicon PLC, HMI, and servo drives. As I told you, one for wrapping, then another for sealing purpose. Okay, there is accurate sealing. Okay, and last is for cutting, because we have seen there are different products with different lengths. So accordingly, cutting should be operate. So here you can see what are the inputs of the system. For example, if you want to pack cookies, so you need cookies and plastic film. So this automate process will process this, and it will pack the products like this. So in this way, you can create your own mini projects or learning projects. So if you want to learn more examples like this, or you want to see more real life examples like this, so show your interest by liking, subscribing, and commenting on our YouTube channel instrumentools.com. Meet you in the another video with another interesting example. Hello friends, welcome to our YouTube channel instrumentools.com. Today in the series of real-time PLC and HMI projects, we have came with another interesting and unique example, that is automatic yogurt packing machine. So let us see how this automatic machine works. So first of all, we will see the complete operation of this machine in actual speed. Okay. Then we will see in slow motion. You can see from the empty cup to the final packaging, complete machine is working fully automatically. And in this machine, there will be servo drives. This is pneumatic cylinders in each station. So for that, there will be reed switch for its feedback and controlled valve for this filling. So everything we are going to see in this video. Right now you have to observe how this machine works, and you can see here there is a rotating table. Generally the production lines are horizontal conveyor type because of space saving, and you can see the complete machine is controlled from here, where you can see motor speed, sealing time, temperature. So if someone asks you to create a machine like this or write a code for machine like this, so it is very necessary to understand each and every operation of the machinery, so that it is clear to you what will be your first code, then what will be your another code. So if you understand any machinery from my point of view, that is I'm showing in my videos, then you will be easily able to create your own logic for that machine. So let us start and understand each step, that is how this automatic machine works. So the first step, that is table rotates. So you can see there are the 5 stations. This is the first station, second station, third station, fourth, and here the 5 stations. So 5 operations are happening over the 1 cup of yogurt. Okay. But all the steps are happening simultaneously, and all the steps occur after the table rotates. This is the circular table. After it rotates, all the operation starts. Okay. You see the table rotated. Now all the operations will start simultaneously. So this is the first step. So it is important that every time this table should come at this particular position only, means it should travel a particular degrees only. So obviously either there will be stepper drive or servo drive, so that every time it rotates exactly the same degrees. Now let us move to the second step. So second step is to place empty cup in the production line. Okay. So you see this is our first station, and this is something called as auto loader. Auto loader means once the operator fills this all empty cups, production line will automatically load one by one into production line. This part is called auto loader part, where empty cups are loaded automatically into production line. So how this works? Once you can see here are the pneumatic cylinder, and for its feedback there will be reed switches in it, and these are the air lines. So for these air lines there will be solenoid valves. For example, if this line solenoid valve is energized, so air will flow from here and cylinder will move, advances. Okay, cylinder advances and it will place the empty cup in the production line, and after a particular time delay, this solenoid valve will energize, so the air will flow from here and cylinder will retract back. Okay, so you can see from here. Now it energized, so it advanced. Okay, and place the cup. Again table rotate, it will advance. You can see table rotated. Again it advances and place the cup. Again retract back. Okay, so in this way this auto loader works. So this is the first station in the 5-step process. Now after placing the cup, each time you have to remember that table will rotate. So our empty cup will go to our next station, that is the filling yogurt. So you can see this is one pipe from where the yogurt is filled into the cup, and there will be motor continuously on, and there will be solenoid valve. So based on the on off of solenoid valve, this cup will be filled. So you can see from here, after the table rotates, empty cup come here and the solenoid valve started filling. Okay. Again solenoid valve off, table rotated, again valve on. So yogurt is coming. So in this way, yogurt is filled into the empty cups. Now again the table will rotate and this cup with yogurt come to this station. Okay. So now we will see what is happening in the next step. So the next step is putting the packing cover. Observe over this part of the machine. You can see this is by suction taking one cover paper and this cylinder is up down and this arm is also rotated. Observe this arm. This arm rotated, cylinder goes up. Now by suction it picks one cover. It came down, arm rotated and placed this cover on the yogurt cup. Okay. Now we will see the next step, that is heating the packing cover. You can see in this step, that is in the fourth step, we have placed a plastic cover over this yogurt cup. Now we will heat this so that it seals. Okay. So the fifth step is heating the packing cover. You can see this particular portion, that this is the next station. So you can see there will be particular die which only hits the circular of this cup. Okay. So this you can see it is moving up down. As the table rotates, it will come down and seals the yogurt pack. Okay. Now the final step to take out the cup from the production line. So now you can see this assembly. Okay. First this cylinder moves upward, then this pneumatic cylinder pushes this cup to this production line. Okay. So you can see came gone down, cylinder up, this cylinder pushes, cylinder up, this cylinder pushes. So this way the cups are taken out from the production line. Now we will see how this machine is controlled from control panel. So you can see this is the control panel where there is start stop button, power indicator. You can see this is the new kind of indicator available in the market where it also shows the voltage. You can see over here. This is the power on off switch and emergency switch. And more functions can be controlled through this Vicon HMI, and this project is also made using Vicon HMI and PLCs. So here you can see this is the heating temperature. This is the sealing time for how much duration you want to apply heating. There is motor speed, motor acceleration and reacceleration time, and more you can see from here daily productions, etc. So friends, this was our video of automatic yogurt packing machine. I hope you find it helpful and you learn something new in this video. If you want to see more content like this, show your interest by liking and subscribing our YouTube channel. Meet you in the next video with another interesting example. Hello friends, welcome to our channel instrumentools.com. Today in the series of real-time PLC and HMI projects, we have came with another interesting project, that is automatic bottle filling. So first of all, let me show you the complete machine. So it is just controlled by HMI, and this is how the machine looks and works like. So bottles are coming automatically, it stops and it fills the bottles. Bottle passes. So this is the complete automatic machine that we are going to understand today, how each and every step is done over here. So this is the HMI. You can see lot of parameters to control from. These are the input output screen. Okay, so you can troubleshoot in case of machine stops and auto cycle doesn't works. Mostly used in the pharma companies. Let us decode how this machine works. So the step one is conveyor on. That means output of the conveyor is on and bottle comes to production line. So let me show you. So first step is turn on the output of conveyor. Now here you can see these are two photo sensors and these are two pneumatic cylinders. So when the conveyor is on, bottles are coming. Along with that, this sensor is counting the number of bottles. When the desired number of bottle will pass through this sensor, let me show you what will happen. Initially, this cylinder is in advanced position, that is in forward position. So you can see its cylinder over here. So bottle cannot go besides this. Okay. Now when the photo sensor will count the desired numbers, what will happen? Conveyor will stop. Nozzles will come down. So when the photo sensor counts the desired number of bottle is achieved, then what will happen? Conveyor output will be off. So conveyor will be stopped and nozzles will come down. So that we can see from here. So when the desired number of bottles are came here, what will happen? This cylinder also advances. Why this cylinder advances? That you will understand in the later part. Okay. Right now, what is happening? Observe conveyor is stop right now and this nozzles. So this will come down by a pneumatic cylinder. So that pneumatic cylinder will have two pipes like this. So for that it will have two solenoids and that will be controlled by two outputs of the PLC. So when the PLC will give command to the down solenoid valve, pneumatic cylinder will push all this nozzle in downward motion. So let's see that cylinder pushes this nozzle down. Okay. Now this nozzle is getting liquid from these pipes that you can see from here. Now how it will fill, that I will show you later. Filling the bottles with nozzle and then nozzles are taken upwards. Okay. So filling can be done based on the two things. Either you can fill based on the time, that first you test by setting the time, you can fill your desired level. Okay. So for that particular time, the pump will be on and the fluid will flow from these pipes to this bottle. And the second method is to keep sensors, capacitive sensors, to detect the desired level is reached or not. So I assume here the filling is based on the time because we cannot see any sensor to detect level here. And after the time has completed, the filling pump will off and after that what will happen? PLC will energize the up solenoid valve. So the pneumatic cylinder will move upward and the nozzles are taken upward. So you can see from here, nozzles are going upward. Now what will happen? Step 4 will be executed where conveyor is on. So the filled bottles will taken out of the production line. So you can see, but before that, this cylinder retracts back. You can see first there was the bar, but now there is no bar and the conveyor is on. So what will happen? Only this much bottles will go from here, and because of this cylinder is lock position over here. So even if the conveyor is on, only these bottles will move and these bottles will not move. So you can watch from here. You can see because of this lock, only this bottle moves because this lock is taken back. Now the role of this photo sensor is to count these bottles when all the, for example here, there are 8 bottles. So when the 8 bottles passes through this sensor, what will happen? Again, it will lock the production line through this cylinder. Observe that carefully. So it locked here and also unlocked this cylinder. And again, this sensor will count 8 bottles. When the 8 bottles are reached, it will again lock the conveyor line. You can see when the desired bottles reached, it locked the conveyor line, and in this way, this whole process keeps repeating. So I hope that you have learned something new from this video. Try to make this by yourself and do a practice. If you want to see more real life projects like this, show your interest by liking and subscribing our YouTube channel. Meet you in the next video with another interesting example. Hello friends, welcome to our YouTube channel instrumenttools.com. Today in the series of real-time PLC and HMI project, we have came with the example that is automatic mattress packing machine. I hope you will also be quite interesting to know how the mattresses are packed. So let's begin our journey. So first of all, we will see the complete machinery. Then we will try to understand its operation. So this is how the complete automatic machine that is controlled through control buttons HMI and the pillows or mattresses are packed. So first you also watch this video and try to see the technical things like inputs and outputs that you can visualize from this video right now. Then I will explain and see how you can grasp it. Matrices is completely pegged, and this is made using Vicon PLC and HMI or the Vicon technology products. Now we will try to understand each and every operation of this machine. We will see the each and every steps. So first step, the mattress is inserted and the plastic is covered. And how this happens? So for the first time, there are the two rollers. First roller upwards and second roller downwards. So for first time, plastic is taken from upper roller to the bottom roller, and in the bottom, plastic film is kept tighted. Okay. Now as the mattress, this is the mattress, as the conveyor moves this mattress inside, so here this roller rotates and the plastic film is released from here, and in this way when the mattress completely goes inside here, it will be covered with plastic film. It will be completely covered with the plastic film. The more will be clear to you in this video. So let me play this. So you can see for the first time, so this is the below portion of the plastic film. Here it was kept tight, and from this roller plastic is taken. As you push the mattress here, the plastic is completely covered to it. So this is the plastic film. It will go, and the same plastic is coming to upward, and here it is the rollers. So this thing only I am trying to explain you from this slide. This was the plastic film. It is going like this and coming up to this roller. As you press this mattress left side, the complete mattress will be covered with this plastic film that is shown over here. As the mattress is completely moved like this, it is completely wrapped with plastic like this. So now what is the second step? The cylinders will push this down, and there will be heaters which are continuously heated, and that heaters will seal this plastic. Okay, so that is the second step. So now cylinders come down. So pneumatic cylinder will push down, and this is the heater bar that will seal this film for particular duration like 1 second or 2 seconds, that is given by operator. Now if you remember, we have sealed only one side of the mattresses, so there will be some air. So before sealing the other two sides, the air is removed. So for that, a cylinder will come down, it will remove all the air. So now watch over here, you can see cylinder is pressing the hole square slide in downward direction slowly. So all the air is taken out from these open sides. The cylinder down limit switch reaches. What will happen? These heaters will come down to seal this side. So you can see it seals here. In the same way, back side also the open side will be sealed. So the mattress is sealed from three sides. First we seal towards this side. Now we are sealing it here and its back side. You can see this all are the pneumatic cylinders. These are the pneumatic pipes. This is the junction box for all the solenoids of pneumatic cylinders. After the particular time duration, these cylinders will go upward, and that is happening by solenoid valves. So PLC will command solenoid valves for upward direction, downward directions. Then the cylinder is completely up. The conveyors are on, so mattress can be taken out. Mattress is taken out to the next station. So in this way, mattress are packed using PLC and HMI in fully automatic manner. So in this way, the complete machine works. I hope you enjoyed this. And if you want to see more real life examples like this, show your interest by liking and subscribing our YouTube channel. Meet you in the next video with another interesting example. Hello friends, welcome to our YouTube channel instrumentools.com. Today in our series of real-time PLC and HMI projects, we have come back with another example, that is LED beads sorting and tapping machine. So this is the two important process that is happening in LED industries. So let us see these machines. So this is the HMI, and first of all here you can see this is the drum where all the LEDs are kept, and this is kind of vibrating drum. So what happens due to vibrating, this organize themselves into a single line and it advance in the spiral form. The LEDs are arranged in single horizontal line and then it is fed to conveyor. So this conveyor takes this LED to next part of this machine, that is the sorting machine, where LEDs are sorted based on their brightness. So let's see that. So this is the sorting machine, and here you can see all these pipes. So these are the different stations that you can see from here, 8, 9, 10. So based on the brightness, LEDs are sorted in this many stations, okay? And how it is sorting, that we are going to see in a few seconds. And this is the complete machinery. You can see how fast this operates. So for this particular machine, these items have been used, that is Vicon HMI, Vicon PLC, particularly LX5E and LX3. Why? Because this particular PLCs have the specific features that I am going to discuss later. Besides this, also the servo motor and servo drives are used for this project. So you can see the important feature of the PLC models I have told you is that it can scan 10,000 steps in just 0.27 milliseconds. So a very large programs can also be scanned in just 0.27 milliseconds. You can see this is very fast machine. Actually, there is the lot of demand and consumption of LEDs in the market, and doing this task manually is not feasible. So we require high speed machine, and for high speed machine we require high speed PLCs. Okay. So now we are going to see the operation of this machine in the slow motion, how this works. So first of all, the LEDs are injected. So as I have told you, from the vibrator drum, LEDs comes to conveyor, and from conveyor, it is injected to this our rotary table. So this is the path from where the LEDs are injected in this rotary table. You can watch it in the slow motion. Here observe this. LED will come exactly at this slot, and after that it will move. So there is also sensor. When LED comes, the table rotates, and the next step is to apply power to the LED and test its brightness. So you can see these are two probes, that is the plus and the minus voltages, which are given to the LED. So when the table rotates and LED is there, these two pneumatic cylinders will advance towards the LED and apply power to the LED. And from the brightness sensor, it will store its brightness, and based on its brightness, it will be sorted in different lines that I have shown you earlier. So this is the different perspective. Here there is no LEDs, but we are showing you in slow motion how it works. So for one LED to check, it takes only 15 milliseconds for particular brightness test. Okay. So this is how fast the machine works. Finally, this machine can sort more than 1 lakh LEDs in just 1 hour. That is its speed, or the overall process from injecting LED to brightness testing and sorting. It takes only 33 milliseconds for each LED. And the final step is to blow out the LED in different station. So observe here, when the LED comes here, and you can see the ferrule over here. For each station, there are the different wires coming. If this wire is energized, if the power will flow from this wire, this particular valve will operate and it will blow the LED in this particular line. So that you can see from here, when it reaches to here, valve is energized and LED is blown out of the production line. Okay. So in this way, LEDs are sorted in the industry. So this whole project was made using Vicon technology products. After sorting the LEDs, the next step is to pack the LEDs. So that is done using LED beads tapping machine. You can see this is the production line of LED beads tapping machine. So first of all, we will watch how this works. Again, there is the vibrator drum, this rotary table and the production line, and this is the packing machine part. You can see this is the packing roll, and here the sealing part is done, and finally here the output is taking from the production line, and you can see how fast the machine works. So to pack one piece of LED, it just takes 52 milliseconds. Okay, and also here there is the vision sensor. In the previous part, we sorted LEDs based on brightness, but here also there is the visual sensor which detects the physically damaged LEDs, and it is taken out of the production line in rejected LEDs. Okay. So this is the control panel. You can see the HMI control buttons, emergency buttons, and the temperature controller for obviously heater. This machine also have servo motors, servo drives. So this is the complete overview of the machine. Again, here you can see the LEDs are put to the vibrator drum, and due to the vibrator mechanism, LEDs rises in the spiral form, and it forms one line, and from the line it goes to conveyor, and from conveyor it is going to tapping machine. And the operation of this rotary table we are going to understand now. First of all, you can see from the diagram, there are the 6 main steps, okay, in this LED beads tapping process. So first of all, from the vibrator drum, LED comes to here rotary table. So first step is the vibrator drum. When the LED beads comes to this position, so this position is called as position number 2. So by creating vacuum, it picks up the LED and the table is rotated. So in this way, LED is picked up, and each time the table is rotated. And finally, when the LED reaches to here, that is the position number 3. Now at the station number 3, vacuum is released. So LED drops on this conveyor, and the conveyor moves to station number 4. So at the station number 4, the vision sensor or vision camera checks the LED for any physical damage. If there is no any physical damage, conveyor again moves forward and reaches to station number 6, where horizontal packing is done. So for that, I have already made a video about the horizontal packing machine. The role is wrapping the product and it is sealing at particular interval. So you can see this is rotary sealing. So in particular space, it will seal and cut. Okay. So this is the packing machine. But what if the LED is damaged? In that case, the conveyor is moved in reverse, and here again the vacuum is created. It will take back the LED from conveyor and it rotates forward to station number 5. And from here, LED is blowed out of the production line as shown in LED sorting machine. So this was the complete process, how actually it looks like. So again, let me show you. You can see this is the station number 1. From here, LED comes to station number 2. Here, LEDs are picked up by creating the vacuum and then table rotates. And finally, after rotating, this is the station number 3 where LEDs are dropped on this conveyor, and this is the vision sensor from where it checks for damage. If it is not damaged, then conveyor will move forward, and this is the step or station 6 where LEDs are pegged. And if the LEDs are rejected, this will again create vacuum and take the LEDs to this section, that is station number 5, and here you can see the lines. So here LEDs are blown out of the production line. Our idea of making such videos is to show you the different mechanisms used in the automation industry and the sensors and the actuators. So it may be helpful to you in some of your projects. So thank you for watching this, friends. If you want to see more examples like this, show your interest by liking and subscribing our YouTube channel. Meet you in the next video with another interesting example. Hello friends, welcome to our YouTube channel instrumentools.com. Today in the series of real-time PLC and HMI projects, I'm going to show you very little but interesting example, that is automatic labeling machines. So friends, you may have seen label or sticker on so many soft drink bottles, medicine bottles and other things. So this is the widely used machine used in various industries. So first of all, let us see the complete machinery. You can see the bottles are filled and it is controlled through HMI about the speed, the length of your sticker, etc. So right now there is no sticker, but from here the stickers are applied, and you can see from here automatically the sticker is applied to the bottle, and you can see the finishing over here. So this is the complete machinery, but don't worry, I am trying to explain the working of this machine. So this was the first complete overview. Now we will understand step by step how this machine works. So first of all, from the conveyor, bottles are fed to this portion, okay? And here there is the roll, and this roll is coming to plate over here. Now this is very traditional method. How we apply stickers? We peel off the sticker, and this is the back side. Okay, so things will be clear when I will show you from the next part of this. So you can see. So this is the back side of the sticker. Here this roll contains both sticker and the backside material, and the roll is coming over here. From this particular portion, what happens? Sticker sticks to the bottle, and this is the backside material of sticker that is again taken back to here. So let me show you. When this photo sensor detects the bottle, this plate will slightly move towards this bottle. So what will happen? That sticker will stick to it, and this conveyor, it will rotate the bottle. So the sticker is applied to circularly this bottle. You can see when there is no bottle, this plate will slightly move towards this direction. This way the stickers are applied. That was the one sensor that I have shown to you. There is also another sensor over here. So you may have seen one black square portion in all the packing materials, where in any packing material, packing pouch or packing bag or bottles. So what is that black square? So here there is the color sensor. Every time the black mark comes to here, this stops. So that particular portion only applies to the one bottle. So this is how the machine comes to know that this portion is going to apply for one bottle. So that one black square mark is in all the packing items that you have purchased. So you can see every time it stops to this portion only. First, the motor of the roller is on, and when this color sensor senses that black mark, this motor is stopped. So in this way, this was a very simple process of labeling the plastic bottles. I hope you enjoyed this video. If you want to see more interesting examples like this, show your interest by liking and subscribing our YouTube channel. Meet you in the next video with another interesting example.